So we've seen lots of different ways of factoring, and today I'm going to try to help you figure out a more systematic method of choosing which method to use to factor. So here I am presented with this somewhat factored polynomial, and the question is this factored completely? Well, I notice that someone's already taken out my greatest common factor and left me with this trinomial. So the next thing I'm going to check for is to see if I can factor this trinomial. Well, of course, I'm looking for numbers that will multiply to give me 7, but add to give me 5. Well, the 7 being a prime number, the only numbers I can multiply to get 7 are 1 and 7. There's no way that I can add those numbers, even if there were negative signs in there, to give me a 5. So in fact, this trinomial here is completely factored. So let's talk about how we might sort of organize that, and I'm going to draw sort of a little flow chart for you, and then in the next slide I have got an actual chart that you can copy down of the different things that you should look for. So the first thing I'm going to do is look for my greatest common factor. So first thing I'm going to do is pull out my GCF. Then I've got kind of three different scenarios. If I'm left with two terms, if I've got a binomial, well, yesterday we talked about looking for the difference of squares. So I'm going to check to see if I have a difference of squares. If I don't have a difference of squares and I've already taken out my greatest common factor, then that binomial is not factorable. If I've got three terms, if I've got a trinomial, then I'm going to look for a pattern. So I'm going to check out my pattern to see if perhaps I've got a perfect square trinomial that we looked at yesterday as well. A perfect square trinomial. And if I've got a perfect square trinomial, great. If not, then I'm going to move to my next option, which is to use my box and T method. And we've gotten lots of practice with that. If we're not finding any numbers that'll multiply to give me my C and add to give me my B, then I'm again not factorable. And finally, if I'm given a 4-term polynomial, then I'm going to immediately look to factor by grouping. And if I can't factor by grouping, then it is also not factorable. A nice neat chart for you. First I'm going to look for my greatest common factor. Binomials, I've got a difference of squares. Trinomials, I've got perfect square trinomials, and then other ways of factoring by using my box and T method, and that's all this is really telling you, that this is from my box and T. And then if I've got more than 3 terms, then I'm looking to go by grouping. I would put either the flowchart or this chart somewhere in your notes so that you can refer back to it for some practice. So I'm going to run through a few problems with you just to show how I'm going through my flowchart. The first thing I'm going to do is look for my greatest common factor. I've got a negative 3a that appears to be common to all 3 terms. So I've got my negative 3a times b squared minus 10b plus 25. Okay, so I've taken out my greatest common factor, and now I look to see that I actually have a perfect square trinomial, because the square root of b squared being b and my 5 5b, if I double that, will give me that 10b term. So I know that I'm looking for a perfect square trinomial, then that's going to factor to b minus 5 times b minus 5, or b minus 5 squared, and then my greatest common factor, and we are now fully factored. Once again, I'm going to pull out my greatest common factor. That's the first thing I'm going to do. 2 times x to the 4th plus 9. Well, this looks like I've got a binomial left. It could be a difference of squares, except that the problem is I've got a plus, not a minus, so I am now completely factored. So here's one more example. I have no greatest common factor to take out of these three terms, and then I'm going to look to see if I might have a perfect square trinomial, but I don't. This one's not going to be a perfect square. So I'm just going to go back to my box method to check to see what I can do. And so I know I'm looking for factors of 45. That's 5 times 9. Factors of 45. Well, my factors of 45 would be 1 and 45, 3 and 15. I've got 5 and 9. And none of these, remember I'm going to have to add, I'm going to have two positive terms. None of these will give me a 3. So now that I've gone through and checked to see, I know that this is not factorable. So for a polynomial of the form ax squared plus bx plus c, if there are no numbers who will add to give me my b and whose product is ac, then my polynomial is unfactorable, as in the last instance. Examples very quickly. Remember, taking out my greatest common factor, I've got a 2y that I can take out here, which will leave me with x squared minus y. And I've got now a difference of squares, so I have 2y times x plus y times x minus y. And one more, taking out my greatest common factor of 3x, leaving me with a 5x squared plus 22x plus 8. I'm looking for factors 5 times 8 or 40 that can add together to give me a 22. Well, if I have 2 times 20, then I can get my 22. So I've got a times c, that number, and these two factors will also add to give me my b. So I know that I've got 20x and 2x as my factors, and I'm going to factor this out quickly. And that'll be 3x times x plus 4 times 5x plus 2. Now I've got a bunch of problems for you to work on. There are 4 on this slide. Go ahead and pause it and write these down. So I've got 4 more examples here that I would like you to factor. I will be giving you the answers in this video, so please make sure you have paused and written these down and tried to work them out. But in the meantime, let me share with you your joke for the day. So have you heard about the mathematical plant? It has square roots. I know, that was hilarious. Here are your answers to the 8 problems we just saw in the video, and we will continue practicing factoring methods in class tomorrow.